This is Freya again, and in this video we will go through 12117 Team 6. So the question is as follows. How many perfect squares divide 21 to the 21st power? The first thing that we want to do if we're going to be looking at stuff like divisibility, or just dividing things, is write out the prime factorization of our given number, which is 21 to the 21st power. So let's do that. So first we'll write out the prime factorization. And so we know that 21 is equal to 7 times 3. So 21 to the 21st power is going to be equal to 7 times 3 to the 21st power. Now we know that 7 and 3 are both prime numbers. So then we can just write this as 3 to the 21st times 7 to the 21st. All right, so here's our prime factorization of 21 to the 21st power. All right, so now let's look at the problem again. So we are asked about perfect squares. So what is a perfect square in terms of its prime factorization? Any perfect square n squared is going to be equal to n times n, and n can have whatever prime factorization it wants. So if n is equal to a1 to the e1, a2 to the e2, sorry, I'm going to call them primes. So p1 to the e1, p2 to the e2, and so on to pk to the ek, then that means that n squared would be of the form, or would have prime factorization of the form p1 to the 2e1, and p2 to the 2e2, and so on up to pk times the 2ek. So why is this the case? Well, we're given our prime factorization of n, which is p1 to the single e1, so then we're going to multiply n by itself. So that means that we're going to have p1 to the e1 times p1 to the e1, p2 to the e2 times p2 to the e2, and so on and so forth, until we get to pk to the ek times pk to the ek. Now remember that exponents are additive when you multiply. That is, a to the b times a to the c is equal to a to the b plus c. So that means when we have n times n, we have p1 to the e1 and p1 to the e1. So then we just add the two e1s and we'll get p to the 2e1, and so on and so forth. So what do we notice about all these exponents of a square? So we can see that each of them is multiplied by 2, which means that all exponents of a square, perfect square, are going to be even. Awesome. All right, so now let's see if we can use this. What we want now is to think about how to get perfect squares that divide 21 to the 21st power. So now we're stepping back and thinking about our 3 to the 21 times 7 to the 21. All right, so each perfect square factor, or any factor at all, that divides 21 to the 21st power is going to have factors of 3 and 7. So let's write this down. And of course, we also know that xy are less than or equal to 20. All right, cool. So we have our form of each of our factors. Now we need to think about how to use this. And then that means that we have to think about perfect squares again. All right, so each perfect square then is going to have an even exponent. So we can then use that and put restrictions on x and y. So that means that our desired factors are going to be of the form 3 to the 2k times 7 to the 2l. Now we need to think about what our possible values of k and l will be. All right, so we know that 2k and 2l are going to be at most 21. And of course, they're going to be at least 0. All right, so what that means though is we can divide both sides by 2 to find that 0 is most K and L, and that's going to be at most 10.5. Now the thing is that K and L are both integers, so really you don't need to think of this 0.5. It's at most 10. So what that means now is we have all possible integers between 0 and 10 inclusive are values of K and L. So that means that there are 11 possible values of each for K and L. So we don't have any further restrictions than that. So now we just need to multiply 11 by 11 to get our final answer for 111 squared is 121 possibilities. That is, we have found that there are exactly 121 perfect squares that divide 21 to the 21st power. Thank you, and I hope you enjoyed this video.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.